All right, so when we study functions, we're going to be looking not just at the transformations, which is what we did yesterday, but we're going to be looking for specific characteristics of those functions. Sometimes people call it characteristics, sometimes people call it key features, but we're going to be looking for different ways to describe those graphs. And there are certain characteristics or key features that we use to describe them. Some of these you might have done last year in Math 2, and then some of them will be new to you. Just like the transformations, we're going to be using these for like the next 6 units. So for this unit, it's going to feel new and maybe a little bit different. And then by the time we get to the 6th unit, this is going to be like easy peasy. We're going to feel like we've done it a million times. Like, okay, these are the easy points on the test. Let me just get these points that I for sure know I can get, okay? So if you have questions or if part of this is confusing, make sure you ask the questions now instead of toughing it out, because this is going to happen over and over and over and over again, okay? So the first 2 features that we study are domain and range. These should be familiar to you because you do talk about them in Math 2. But the domain is all of the x values or all of the inputs. All of the inputs that are defined in a function. This means that you can plug a value or plug a number into the function and get an answer. So we know that there are some things where you're not even allowed to plug in certain types of numbers. Like with the square root sign, you're not supposed to plug in negatives. With a fraction, you're not supposed to plug in a 0 on the bottom of a fraction. There are things where your calculator would give you an error message. For other problems, you can plug in whatever you want. So the domain has to do with what you're allowed to plug in. So domain are all the inputs that you're allowed to plug into a function that will spit out an answer on your calculator. That's the domain, the x values. We always think of this as, if I look at the graph, it's how far left and right I can look on the graph. Okay, x values, left and right. The range is all of the y values or the outputs that are defined in the function. So basically, this is the answer that you get after you plug values in. Sorry, my blanks are a little bit wonky. We didn't really need that blank down there. This is the answer that you get after you plug the values in. So if you plug all of the possible values into a function, what are the different answers you can get as a result? That's what the range is. It's all of the different answers combined together, and then you think it through. So in a graph, that would be all the up and the down. How far up the graph can go, how far down the graph can go, that's the range of values. So right next to this, I'm going to put an X really big. I'm going to put a Y really big so that I can just glance at my notes and remember which one is which. Okay. So we're studying absolute value graphs, and so these domain and range example problems have to do with absolute value specifically, since that's what we're studying. So if we look at this problem, I'm going to write the vertex down for both of these because it's going to help us with some of the answers. So if we look at example 1, what is the vertex for example 1? Positive 3, positive 2. Okay. And if we look at the graph, if we consider the domain and we look at like how far left does the graph go, how far to the right does the graph go, on the left side I can see an arrow, on the right side I can see an arrow. So this graph is one that's kind of like, here's the middle of the graph, it starts in the middle and it goes left forever. The arrow means it goes forever, starts in the middle, goes to the right forever. So for us to be able to write that mathematically, that for our domain values as far as possible x values, we're going to say left forever, negative infinity means left forever, and then right forever is positive infinity. This graph goes to the left forever and it goes to the right forever. And anytime you put infinities on your paper in math, we always put parentheses around them to just say, okay, that answer is from negative infinity to positive infinity. Now, the range for this graph is going to be slightly different if we think about how far down does this graph go to how far up does it go. The bottom of the graph is arrows for both pieces on the bottom. On both sides, we have arrows going down. So this graph goes down forever. Now, if we think about how far it goes up to the vertex, and then it stops right there at the vertex. So which number describes how far up it goes? The 2. The 2 describes how far up it goes. So it goes down forever, and it goes up to 2. So I'm going to say this graph goes down forever, and it goes up to 2. So whenever they go down forever, I'm going to use a parenthesis. If they go up to a number, and that is a specific number on the graph, you can see it with your eyes, and if somebody were to ask you where the number is, you could put your pencil on it. You can actually see exactly where that number is. You put a bracket there. If that's something real, it actually shows up on the graph. For the infinities, if somebody said, Miss Rice, where does the graph go right forever? If I try to say right here, they say that's not forever, that's 8. Because that's where x equals 8. So even though I put my finger where the infinity, or where the arrow is, that's not actually the number infinity, that's just the number 8. Okay? If they say, show me where the graph goes down forever, I'm showing them, oh, the graph goes down forever right here, but that's not down forever, that's not negative infinity, that's actually negative 3. So that's why we put a parenthesis there, because we're not actually putting our finger on negative infinity. Okay, but here when we say where's the top of the graph, where's 2, if I put my finger there, I'm actually putting my finger on 2. Okay? All right, let's try the next one. What is the vertex for the second example? -4, -7. Okay, vertex is -4, -7. Okay. So first question, how far left does the graph go? How far right does the graph go? So to the left we see an arrow, to the right we see an arrow. So how far left does it go? How far right does it go? Infinity to the left, so negative infinity. How far to the right? Infinity. Okay. So the domain is from negative infinity to positive infinity. Forever to the left, forever to the right. Okay? Next, we're going to look at the range. How far down does this graph go? How far up does this graph go? So it goes down to -7. It goes down to the vertex right here at -7. Okay? And then how far up does it go? Infinity, because it goes up to arrows, and up arrows are infinity. Okay, now infinity, I can't touch that. I can touch the arrows but not the number infinity. What about the -7? Can I touch that with my finger? Yes, I can touch -7. It's right there, so that gets a bracket. Okay, we good so far? All right. The vertex is the point where the graph switches from increasing to decreasing, or vice versa. So in this graph, it switched from increasing to decreasing right here. So this is the vertex. In this graph, the opposite happened. It went from decreasing to increasing here at the vertex. So the graph is increasing if it is slanted up. It is decreasing if it is slanted down. Okay, so the vertex is just that corner point where it switches directions or if it's a smooth curve, it's kind of like a mountaintop or a valley where it switches directions. All right. Some graphs don't have a vertex. They don't have a point where it switches directions, but they do have a point that seems similar in nature. They do have a point that's kind of like the middle of the graph. We can call this the locator point. That's a name that I, Miss Rice, have given the point. I've seen other math teachers use it as well. It's not necessarily a name that all math teachers use, but it's kind of helpful to have something to call it. So I'll let you guys know when we get to a unit where we're studying something that doesn't technically have a vertex. If you call it a vertex, I will not get mad at you or mark you down or anything, but there are some units where we technically shouldn't call something a vertex because by definition they don't have one. Okay, I'll let you know when we get there. The vertex and the locator point are found in the equation using the h and k. We talked about that yesterday, and we do h comma k. So that's what we did up here when we circled the 4 and circled the -7. The 4 was the h value. That's how far the graph moved to the left or the right with the transformations. And then the k is the number on the end. That's how far the graph moved up or down with the transformations. And so that was the other value, h and k. All right, so that's the only part of those notes that we're going to do today. We can go back to that assignment from yesterday. And now we're going to look at number 19 and 20. So 19 and 20, and actually we didn't do number 18 either. So 18, 19, and 20 you can do. 18, 19, and 20. 19 and 20 specifically ask you to do the domain and the range. And all you really need to do for these, you can graph them on a calculator, but you technically don't need to. But all you really need for these is you need to be able to picture, does the V shape of the graph, does it go up or does it go down? So if we look at number 19, based on the equation itself and the transformations you can see, would this V be right side up or would it be reflected over the x-axis and be flipped upside down? It would be right side up. I can tell because of the 2 in the front, that number's positive, and so that V-shaped graph would be normal, just right side up. Okay? For 20, if we look at that graph, that equation, would that V be right side up or would it be upside down? It would be upside down. Okay, so if you want to graph it on a calculator, you're welcome to do so. So that you can see more of the graph instead of just the V shape. But this is enough information using this and the equation to find the vertex. You're actually able to find the domain and range just from these little sketches. Okay? Yeah.
So for h of a, do we write the absolute value of h or the opposite?
Opposite sign. Opposite sign. Good question. Mm-hmm. Okay, so go ahead and work on, if you haven't done 18 already, go ahead and work on 18, and then we're going to do 19 and 20. And once we've done that, then we'll switch over to doing the assignment for today with the absolute value equations. All right, so 18, 19, 20. Okay. What problems look intimidating? 5. Let's do 5. Okay. So for number 5, our first goal for a problem is we need to have the absolute value symbol and everything inside of it alone on that side of the equation. We need this to be alone. We need all the numbers to be on the other side. So I'm going to leave this part here. I need the 1 to move over to the other side with the 0. How do I move the 1? I subtract it. So I have the absolute value of n divided by 10 equals -1. Now, what happens when absolute value stuff equals a negative? It's no solution because absolute value is talking about distance. This is saying a distance is a negative number and distances can't be negative, so we say no solution. Now, if it was not a no solution problem, we would have set it up, we would have done 2 equations. And to get the n alone, how would you have gotten rid of the 10? You would have multiplied it because it's division right now. So to undo division, we would have multiplied it. So we could have done that even though it's a fraction, feels a little intimidating. We could have been okay with that, okay? But the negative tells us to stop this problem. It's no solution. Okay, what's another problem that looks a little intimidating? 8 looks intimidating. Okay, so instead of 8, because that's one of your assigned problems, we're going to do number 9, which is a little bit more intimidating than 8. Okay, so for number 9, our goal is to get this absolute value alone on this side. Okay, so first step, is there anything that we could add or subtract over to the other side? We can subtract the 9. So, did you have a question? We can't combine those together because the 7 is a coefficient of the grouping symbols. They're not parentheses, but they're grouping symbols. And we have a coefficient of the grouping symbols that should be multiplied. So for us to undo a 7, we'd actually have to divide the 7. So we can't add those together. Does that make sense? Okay. So we're going to minus the 9 and we're going to minus the 9. Okay, so we have 7 times the absolute value of 8 plus 3v equals, what do we have? Negative 49. Okay, and then for us to undo the 7, what should we do? Divide by 7. Yeah. So we're running into exactly what we ran into on the next problem, which means we're going to have to do another one. Negative 49 divided by 7 is negative 7 and no solution. There are, I want to say there's like 4 no solution answers on this page, but I didn't realize we were going to happen to do 2 of them. Okay, let's go ahead and do number 8, since that one felt intimidating. Okay, so for number 8, how shall we get it started? Divide it by negative 10. Perfect. And that ends up making this one not a no solution problem, which is good. We can actually do something here. Okay. So when we end up with the absolute value equaling a distance of 9 equals 9, now we can say, all right, there were 2 equations from this. There were 2 ways we could have gotten that distance of 9, right? What were the 2 ways? Negative and positive. Okay, so what should I be writing? Okay, so the negative version of the inside could be a distance of 9, or the regular version of the inside could be a distance of 9. So the negative version of the inside or the regular version of the inside. All right, which one you guys want to solve first? The negative. Okay, so what should we do with this negative sign? Distribute, okay. So negative times negative is positive 1. Negative times a positive, negative 10n. Okay, so positive 1 minus 10n equals 9. And then what should we do? Subtract the 1. Negative 10n equals 8. And then divide by the negative 10. And we can simplify that a little bit. 8 divided by 10, 4/5. And when you have the negative on the bottom of a fraction, people typically move it out to the front or they just move it to the top. So n equals -4/5. Okay? And then for the other one, what should we do? Add 1. 10n equals 10. Divide by 10. N equals 1. Okay. So just a reminder, negative answers are not a problem. It is only a problem when you have that an absolute value equals a negative. Your final answer, the variable can equal a negative number. That's not an issue. It's the absolute value that can't be negative. Okay. Let's flip over to the back side and see if we see any problems that are intimidating on there that we want to do something similar to. Are we intimidated by any of these? Should we do an example? What do you guys think? 18? Okay, so 18, kind of similar to 15. Let's go ahead and do 15. So for number 15, how should we start it? Subtract the 2. Okay, so 5 times the absolute value of -1 minus 6b equals 65. Then what do we do? Divide by 5. 65 divided by 5, 13. Our absolute value is alone. It equals a positive number. Can we keep going or do we have to stop? Keep going. Okay, so there are 2 versions. What are the 2 versions? Negative and positive. So the inside could have been negative, and so it had a distance of 13. Or the inside could have stayed the same and have been a distance of 13. Okay, so what should we do over here? Distribute the negative. We get +1 plus 6b equals 13. And then what do we have to do? Subtract the 1. And then what do we have to do? B equals 2. Okay? And what do we have to do over here? Add 1. This one's going to be a fraction. What's the fraction? Seven over 3, and you can put the negative anywhere you want. Most people would put it in the middle or on the top. But anywhere in the fraction is fine. All right. Do we feel comfortable working on these? Okay. So the idea with the flipped classroom is that the evens would be, we have about 30 minutes. So we're going to work on the evens. We should be able to get most of them done during class if we're pretty focused. And then for homework tonight, we would finish these up if we have any left over and then watch the video that I will post. Okay? So you don't have to submit a picture of your notes because right now I'm just checking them in class to make sure you have them. Okay? So get as many of the evens as you can done. I'll check back in at the end of the period, see how we're doing. And then tonight, for sure, we will have a video. Okay? All right, so go ahead and get started and let me know if you guys have questions.